Let's get down to it. Okay, so we had done this quadratic type of equations, which I was calling as the U substitution. So we started with that, and we looked at example 6. So now let's go ahead and take a look at how to do the other two types in this. So we're looking at number 7 here. Okay, so here we're given x squared plus x inside parentheses. You've got a square on the outside, negative 8, again in parentheses, x squared plus x, and plus 12 equals 0. So if you remember, as we were talking about this last time, I had mentioned that always look at the middle term and look at what kind of x or your variable value the middle term has. So you will see our middle term has that whole x squared plus x as its value with the coefficient 8, right? So that means when we're doing u substitution, we are actually going to let our u be equal to that entire parentheses part, which is x squared plus x. Okay, so that means when we go back and do that actual substitution with the u, you're going to be replacing this x squared plus x with u, with the 8 next to it. And then the first one would be u squared, yeah, because you've got x squared plus x, the whole quantity to the second value, right? So when we do the substitution, the x squared plus x, the whole quantity squared, will now become u squared minus 8, again replacing that x squared plus x with u, plus 12 equals 0. So we have given it the look of a quadratic equation, right? And of course, it looks less complicated than having that whole x squared plus x in there. So at this point, you again have the option of using factoring, completing the square, quadratic formula, any of those methods. If square root property works, you can use any of those methods to solve this. Again, I prefer going by factoring because factoring to me seems the quickest way to go about it. If you're not comfortable with factoring, you can try quadratic formula. So if we needed to use factoring, are there any two numbers that multiply to give us 12 but add up to give us negative 8? Yeah, very good. So we are looking at two numbers, product 12, sum of negative 8. So negative 6, negative 2 multiply to give you positive 12, add up to give you negative 8. So this guy will factor into u minus 6 and u minus 2, set it equal to 0, right? And then take each factor, because now we're using the zero factor property. So you're doing u minus 6 equal to 0, or u minus 2 equal to 0. Get the u by itself, add that 6 to both sides. On the other side, add that 2 to both sides. So you get u equals 6 or u equals 2. So technically, we have now solved the quadratic part. Now we can go back and bring in the original value that we set our u equal to. And again, u was x squared plus x. So now we are going to replace your u with x squared plus x, which will equal 6, or x squared plus x equals 2. You can kind of think of that as being a back substitution, right? Because we're bringing back the original value that you set the u equal to. Now, this is a unique example compared to what we had looked at example 6 last time. Since you have an x squared plus x on the left-hand side, that x squared is telling you have, again, quadratic equations here. So in this case, I would actually go back and move those 6 and 2 to the left-hand side, get your trinomials, and then I would try factoring. If factoring doesn't work, then I would try quadratic formula to solve each of those two branches for this. So basically, after we do that u substitution back into the x squared plus x, we're now subtracting that 6, which will end up giving us x squared plus x minus 6 equals 0. Or if we are subtracting this 2, then that will end up giving us x squared plus x minus 2. Right here or here?
That we have to sub it back in.
Yeah.
So that, if we answer it like that, it should still be.
But then how do you find your x values? Because our ultimate goal is to find x, right? Not the u. U was just to help us clean up the problem. So to be able to solve the x value, and you know the reason why I don't bring in the x squared plus x here, because if you're comfortable with the signs and everything, you can do it, but I've noticed this is usually where the sign errors happen. So usually I take the 6 to the other side, so you know the u is equally getting replaced with x squared plus x, and then you just bring the 6 and the 2 back to the left-hand side. But if you're comfortable not moving the 6 in between and making the substitution, you can try it that way. I'm tempted to think, what factoring work? Two numbers that multiply to give us -6 but add up to give us +1. +3, yeah, very good. So you can factor that left-hand side into x minus 2 and x plus 3. And again, remember, -2 times +3 gives us -6. But when I add +3 with -2, I get +1, right? That's my middle term. So that's going to give us 2 answers from there. Go ahead and get those answers and then see what you can do with that right-hand side, which is the x squared plus x minus 2. Does that factor, or what happens with that guy? So again, I'm going to take both my x minus 2, set it equal to 0, take my x plus 3, set it equal to 0, and we get our 2 answers from this half. So this will be x plus 2. Sorry, add the 2 to the other side. X equals 2, yeah. And x equals -3, very good. That's the idea, with the x squared plus x minus 2. So again, two numbers that multiply to give you -2 and add up to give you +1. Okay, and then what do you do with the signs? One is negative? Is that what you said? No, because if both were negative, then your 2 would have a positive sign on it. But since 2 is negative, you have to have opposite signs. Jacob?
So the -1.
-1, +2? Yeah, very good. And again, when you multiply -1 with +2, you get -2. When you add -1 with +2, you get +1, which is our middle term. So you should again get 2 answers from here. Take x minus 1, set it equal to 0, or x plus 2 equal to 0. Let's see, we're adding 1 here, subtracting 2 there, and you get x equals 1 or -2, right? So our 4 answers in this case are going to be, let's see, -3, -2, +1, +2. And if you look at your original problem, you started out with x squared, which was again raised to the second power, right? So x squared times x squared gives you x to the fourth. So that original problem is actually a fourth degree polynomial. So it's no surprise that we ended up getting 4 answers for our x value.
So we don't go back and plug those into the equations for the.
You can, just with time constraint. I don't check these, but you can. It's only the ones where you started out with, remember the square root of x, where you can end up with an extraneous root. Those ones we definitely have to, but with these ones, since you didn't start out with a square root, you're not going to end up with an extraneous root. So with these ones, we can take the liberty of skipping the checking process. But if you check all 4 of them, you should get a true statement for all 4 of these answers. Of course, there's always a possibility we messed up and did something with our math or our science, which is always a possibility. Okay, very good. Any other question on this problem? Okay, so let me show you that original one again. So this is what I was talking about. You've got x squared to the second power, which makes this x to the fourth power, right? 2 times 2 will become 4. So since this is a fourth degree polynomial, we ended up getting those 4 answers. Now look at number 8 and tell me what the u substitution should be for this one. You've got x to the 2/3 minus x to the 1/3 minus 6 equals 0. Very nice. Use the middle term, yeah, which will tell us so u is equal to x. That's all I heard. Yeah, very good. So the middle term is going to be replaced by the u substitution. So again, we would say let u equal x to the 1/3. Yeah, yeah. Because otherwise you will have to do trial and error, and you will always still end up with that same conclusion of the middle term. So now the question is,
why does that negative sign not carry?
because we'll keep that with the u. So we'll keep the u as negative u, yeah. So if u is x to the 1/3, then what is u squared going to be? That's the idea, right? So I want us to check this just to make sure you know why the first term will become u squared. So if I'm defining u as x to the 1/3, which means I am saying, okay, if it's u squared, it should be x to the 1/3 squared, right? Now remember, and this is coming from rules of exponents. If you're a little rusty, you can go and review those. When you have one base with 2 exponents, which is what we have here, with x to the 1/3 and then to the second power, you end up multiplying the exponents. So if you are multiplying the exponents, you are multiplying 1/3 with 2, what will you get? 2/3, exactly. And that's why that leading term is going to end up becoming u squared. Yeah, that's basically the idea, because you know from the first 2 terms, if you took the x to the 1/3 out, you would be left with x squared on that first term. Yeah, very good. Okay, so let's do our substitution then. Good. So you said u squared minus u minus 6. Yeah, very good. That will be your u substitution. Everybody okay so far? Sure. Sure. That's a treat for me, yeah.
Write it down.
So you've actually done the hard part already, Brandy. Now you're just trying to solve. Are on the right path. Okay, so just looking around, we are trying to find two numbers that multiply to give us -6, and since there's no number on that middle term, it's understood to be 1, which means you're looking for two numbers that multiply to -6, add to -1, right? Which will come from, I think the other way, right? -3, +2, because we want the larger number to be negative, so our 1 will stay negative, right? Okay, so the factors are going to be u -3 and u +2. And then using your zero factor property, take each one. Very good. So subtract 2, add 3. Levi, did you get this answer? You're still going over it? Okay, did you at least make it this far? Okay. Or the 1/3? You're still kind of thinking the original? Not yet. Right, yeah. So that's the reason of doing U substitution, is go through the process with cleaner values and then bring the not so happy numbers in, right? Then this is where the not so happy numbers are now coming back in. So once you get U equals 3 or U equals -2, now go back and use the value of U, which is x to the 1/3, right? What we started out with. So now I'm going to replace this and say x to the 1/3 equals 3, or x to the 1/3 equals -2. Now this is actually where I saw some of you were kind of wondering, okay, now how do we get x by itself? So let me pull that problem back up just a quick second. This is the number 5 that we had done last week. So you're actually back to this process now, with the exception we don't have a negative sign on our value, right? Because we have x to the 1/3 equal 3 and x to the 1/3 equal -2. So our exponent, our exponent is not a negative value. That's the only difference, but you are going to use the same process that we used here, which was we then raised both sides of our equation to -5/4. In this case, we will raise both sides of our equation, and since these guys are positive, to +3/1, which is actually technically just 3, right? But this is just to show you you're inverting that exponential format. Just to show you what happens when we multiply 1/3 with 3/1. Yeah, very nice. It becomes 1 because technically those 3's cancel out, giving you just 1, which is the reason why we flipped our exponential value. So these guys will actually end up becoming 1, giving you, that means just x on this side. And what is 3 to the 3rd power? 27, yeah, 3 times 3 times 3. So x equals 27 from that one part. Repeat the same process here. You've got x to the 1/3 equals -2. Again, flip 3/1, 3/1. Whoa. This whole thing here will again become an x, -2 to the 3rd power. That's -2 times -2 times -2, right? Two negatives will become positive, but we'll still have a negative sign left behind. Very nice. -8. Those will be our two answers. And this is still a 2nd degree polynomial because we still had x squared as our first term. So this guy would be -8, positive 27. You want to do one more like this? Okay. Okay, so that's our problem. So what's your u value then? Actually, it's only going to be q to the 1/2. Yeah. Very nice. Yeah. So u squared would basically be q to the 1/2 squared. 2 times 1/2 will come out to be 2 times 2, which is 1. So it ends up becoming just q. Okay, so by substitution, you will have u minus what? Or actually, sorry, u squared. Yeah, because we didn't use the 5, right? So the 5 will stay with the problem. So that's 5u plus 6 equals 0. I will try factoring again. So two numbers for +6 and -5. Tell me those combinations again. Okay, so if I multiply -6 and +1, my product is -6. But our equation has +6 in it. -2 and both numbers negative? Yeah, very good. Because that way, if both my numbers are negative, when I multiply, I get my +6. And when I add, we get our -5, right? And another thing, and again, this is something we kind of talked about last time. My constant term is positive, middle term is negative, which means both my factors have to be negative. So that means both our numbers have to be negative. So this will be u minus 2, u minus 3. No, you can have u minus 3 first and then the u minus 2. So take each factor, set it equal to 0. And our u values are going to be, very good, +3 and +2. Okay, you're on your own from here on. Let me see what values you get for x, or q, I guess, in this case. Got your answer already? You got your answers? Not yet, okay. Okay, so once you got the u equals 2 and u equals 3, what do you do?
You're gonna set q to the 1/2 equal to 3, and you're going to say 2 to the 1/2 equal to 2.
Okay.
Then you're going to take that 1/2 exponent, you're going to flip it. So it's going to be 2 over 1. So you put 2 over 1 on.
Yeah, same thing. Yeah, let me just square it in. So, Jacob, you said actually like 2 to the 1/2 equals 3.
Yeah,
2 to the 1/2 equals 2.
then you take that exponent and you flip it. So you're
Yeah,
going
so
to
it
get
will become 2 over 1.
2 over 1 on both sides, which is just 2. So you take 3 squared and 2 squared. So it's going to be 9 and 4.
Very nice. Nicely done. Yeah. So we're going to have q to the 1/2 equals 2. Q to the 1/2 equals 3. This is basically a square root. Yeah, 1/2. Yeah. Yeah, so since these are rational exponents, right? You always want to invert your rational exponent and raise it to both sides, which will help you clean up the left-hand side and then whatever answer you get on the right-hand side. So then you just end up getting q equals 2 to the 2nd power, which gives us the 4, right? And then this guy will give us q equals 3 to the 2nd power, which is your 9. Okay. So equations involving absolute value. Now we've done a little bit of absolute value equations in the first half of this chapter. Do you remember how do we start by setting up an absolute value equation? The absolute value symbol, yeah. All right, so how do we get rid of that, Levi?
Don't you bring the 2 over to the other side?
Nope. Before you can even do that. Because right now, our left-hand side is sandwiched between slashes, also known as absolute value symbol. So you have to find a way. You do need to get rid of those, right? But how do we do that?
Sorry.
Well, that's a big fat zero for you.
I don't know.
Oh, come on, we talked about this. Yeah, because remember we talked about absolute value being a distance from 0, right? See, now he's like, I remember. So don't erase them. So the idea is I can have a distance of 2 on the positive side and a distance of 2 on the negative side, right? You actually set this up as 2 parts where one of them will be equal to positive 2, the other one will be equal to negative 2. But when you split it up, you don't need to put the absolute value symbol. So you will have x squared minus x minus 4 equals positive 2, or x squared, very good, minus x minus 4 equals negative 2. And now you can bring your 2 over to the left-hand side because we always want our quadratic to be equal to 0, right? So that's really the only difference is since these are given to us in absolute value symbols, and we know absolute value can be a distance from 0, either on the positive side or the negative side. That's why we set it up with once on the positive side with positive 2, once with the negative side with negative 2. Okay, so let's bring those 2's and negative 2's to our left-hand side. I'm going to subtract 2 here and add 2 here. Yeah, I believe it that you were joking. It's okay. We have to have a little bit of humor. So x squared minus x, and what does that left-hand side become? Negative 4, negative 2 will be negative 6 equal to 0. And negative 4 positive 2? Very good. And then again, you can factor each one of those. So this guy, what will he factor into? Very nice. X minus 3 and x plus 2, right? When we multiply negative 3, positive 2, we get negative 6. But then when we add negative 3 with positive 2, we get negative 1, which is our middle term. What about x squared minus x minus 2? Very nice. X minus 2 and x plus 1. All righty. So it looks like we end up getting x minus 3 equals 0, or x plus 2 equals 0, or x minus 2 equals 0, or x plus 1 equals 0. Right? 4 answers again. And what are those answers? Very good. X equals positive 3. X equals negative 2. Positive 2. Very nice. Nicely done. So let's see. Negative 2, negative 1, positive 2, positive. Right, it's absolute value, but not just because of that, it's a second degree absolute value, right? So since we set this up in two scenarios, if you're going from the positive side, you can have those positive 2, positive 2. If you're going from the negative side, you can have negative 2, negative 1. Yeah, very good. Anybody else have a question on that number 9? Let me put it back so you can look at that last part again. Try number 10.
Do we ever have to plug these in? Like on a quizzes or anything you want to plug them
So
in?
unless and until you're unsure about your math, you don't need to check. Because again, you're not ending up with an extraneous root in this case here. Yeah. But are we scared? What, you scared of number 10?
Well, there's two lines I've got. There's two sets of lines I've got to write.
Two flashes. So, well, you still got to set it up in two ways, right? Because it's still absolute value. One side could be going to the positive, one to the negative. No, you shouldn't. Because our x doesn't have a square on it.
So, but there's two x's. So it's two x. Wait.
Well, they should combine together, though, right? If we bring like terms together. What were you saying, Iris? I don't have the solution for this guy written out, so I'm not sure what the answer is. I'm hoping it still gives us two answers, but when we solve for it, we'll know. So the first part is setting it up into that one positive side, one negative side. How will you do that? So your first setup would be x equals what? X minus 1, okay? That's one setup. What will the other setup be? Oh, you are so close. So you said negative x equals what? No, so you don't want to put negative on both sides. So remember how we did the previous example, we just made 2 a negative number, but the left-hand side stayed untouched, right? Which means you only introduce negative on one side. So there's 2 ways you can do this. Okay, so for number 10, oh, don't do that. Okay, so this is what we got. The first setup is as Christian mentioned, the same without the absolute value sign. So that setup is straightforward. Or, as Herbert mentioned, you can do negative x, but if you're putting negative on the left-hand side, then leave this guy untouched. Or, you can also write this as x as it is and put the negative on the right-hand side. So do one or the other.
So it would be negative x equals x minus 1.
Yeah, you're just bringing negative on one side, not both. And let me go back and show you what we did here. So when we set this up, we kept our left-hand side the same, right? No changes, just dropped the symbol. And then one side was positive 2, which was the same as the original problem, and the other was negative 2. So that's the same thing we are doing here, where the first part is basically the same expression without the absolute value symbol. But then you're either bringing negative to the left-hand side or bringing negative to the right-hand side, not both, though, right? Because otherwise, you're actually going back to the original if you put negative on both sides. So just on one side. And you know what? If you don't want to worry about distributing that negative sign, then you can leave this here. Just put it on the left-hand side.
So the one on your left hand for the x will cancel out.
Yes, they will, right? Because you'll get 0. So you do only have one answer. See, I was kind of hoping from each side we would get, but yeah, you're right. This guy's gone. Because when we do negative x and negative x, they both cancel out. And which is a false statement, yeah. So yeah, I remember right. I didn't remember that. Did you do negative x plus 1? And then what did you do with your x value? Okay, so you still want to bring your like ones together. So then, since you move the 1, now move the x to the right-hand side. And you should still end up losing that x. Right? So we should still have no x from one side, which is my left-hand side in this case. And then here, if I subtract this x, what do we get? Very nice. Equals negative 1, right? Because the x canceled out, but that negative 1 will still stay. So what's our x? Yeah, very nice, because when you divide both sides by negative 2, which ends up giving us x equals negative and negative is positive. And that's our only solution. So just one number actually from this guy. But this is the crucial part, is how do you set up the second half. Okay, just to show you the one I have in red here, if you had set it up like this instead of the other way, you would have x here. We would need to distribute this negative sign. So we would have ended up with negative x, negative x. Yeah, negative x positive 1. And then again, when I would have moved my x to the other side, that would become what? Positive x. These guys are gone. We end up getting 2x equals 1, and you would still end up with that 1/2 as your answer. So really, it wouldn't matter. Okay, let me kind of try and summarize this. With absolute values, you have to consider the fact that I could be going on the right-hand side of my number line, or I could be going to the left-hand side. So that's why we always set up absolute values in 2 parts. So the easiest way to think about it, the first part is going to be same as the original expression.
Just you don't have to worry about putting those absolute values in, right? So one is directly as the original problem without the symbols. But the second one is where you have to introduce a negative. So only on one side, either introduce a negative on the left-hand side or introduce a negative on the right-hand side. Don't do it to both sides, because if you do it to both sides, you're actually going back to the original part, right? So only on one side and then go through your math. And in this case, this didn't give us any answer, so you're actually only coming up with one single answer as x equals 1/2. Question on 10.
Alrighty, so this is,
Say that again?
with the absolute value, probably just a couple, not too many. Not too bad. Yeah. Because you have x on both sides of your equation. You'll be fine, Levi, don't worry.
Okay, this guy, what are we going to do? They're giving us the function or the equation. D, which represents demand, P is the price. So they're telling us D equals square root of P minus square root of P minus 400. This gives a monthly demand for custom-made suits at price P, right, in dollars. So they want to know what will be the price if the demand for the suits is 10 suits.
So you set 10,
You said 10 is D, very good.
so 10 equals.
Yeah, so let me get back here. So they're telling us demand is 10 suits, so that's your D. Very nice, finding the price. Before you square them, what should we do? No, because the other one has the minus 400 in it, so we cannot combine them. So this is similar to what we did last week with numbers 3 and 4.
When you add the square root of 2 minus 400 on the other side.
Yeah, remember you got to isolate your radicals, get them on each side. So you can start by adding either one of those. Let's do the P minus 400. So he cancels out, giving us 10 plus square root of P minus 400 equals square root of P. Okay. Then what should we do? Okay.
But how can you
So-
square it on a P?
If you want to get your life a little bit simpler, and trust me, you want to make this problem as simple as you can, move that 10 to the other side, or you're looking at a much more complicated problem. And I'll tell you why. So if we subtract that 10, move it to the other side, we're going to end up getting square root minus 400, because think of him as the big bad wolf, right? Because there's two terms inside that radical. This guy will just become square root of P, and then on the outside, minus 10. Because what happens when we try to get rid of a square root? That would be if you were applying the square root. Here we're getting rid, because the square root is already given to us, right? So we're getting rid of the square root. You're going to do a square, and remember, these are the types of problems where you end up getting that extraneous root, the extra answer. So this is what we're going to have to look for. So to get rid of the square root, we need to square both sides of our equation. And here's what I'm kind of talking about. If you left the 10 on the left-hand side, then you would be doing a square on that entire thing, right, with the 10 plus. And then remember, you got to FOIL this, which means you would have to take this into consideration as you're doing the FOIL. But if I move that 10 to the other side, then I'm just looking at square root of p instead of that whole binomial part. So you're working with slightly smaller. It will work the other way. It's just going to take a couple extra steps because of that p minus 400 in there. So that's why we're moving the 10 to the right-hand side. On the left, square root and square cancel each other out. And now you just have p minus 400, and you're done with that guy. We are.
Would it matter if you could start like 10 first and then the big square root of p times 400 or no?
Oh, it wouldn't matter, yeah. As long as you keep the bigger radical, the bigger square root by itself, and don't do the plus 10 with it.
No, it would just be p minus 100.
Right, so the radical and the square cancel out. And then on the right-hand side, you're going to need to remember FOIL this. So that's what I'm doing here on the side. So FOIL means we start with the first, which is square root of p times square root of p. So that's actually going to become square root of p squared. Then you are going to do square root of p times negative 10. That's the O, so that's negative 10 square root of p. Then the I will be this negative 10 multiplied with this square root of p, which will also give us negative 10 square root of p. And then the last would be negative 10 multiplied by negative 10. 10 times 10 is 100. Take it slow, go step by step. So again, first, outer, inner, and then the last. Clean up the middle terms, these guys will combine. Oh, and the square root of p and square will cancel out. So just p, negative 10 will add up to negative 20, square root of p plus 100.
Again, let me iterate the fact. If you left the 10 on this side, this middle term would then have become square root of p minus 400. So that's how if you did move the 10 with the smaller left square root term than the larger one.
So your right-hand side is now p minus 20 square root of p plus 100. So does anybody remember what we did? I think this is example 4. What we did to move next.
Wouldn't you combine like terms?
Combine like terms and try and isolate that middle term, right? Okay, so let's start by moving, I guess, the p from the right. So I'm subtracting this negative p from here. And what happens? Yeah, because that p will cancel out. Negative 400 equals negative 20 square root of p plus 100. What can you move next? Very nice. So subtract that 100, move it to the left. Good. Okay. Will 20 go evenly into 500? Yeah, we don't have to worry about fractions, right? So you can actually divide both sides by negative 20. Take the sign with you. So only square root of p on the right-hand side. 2 negatives will become positive. Yeah, because, okay, so just a quick trick. I have a 0 and a 0 on my numerator denominator. I can actually cancel it out. It's the same as if you reduced by 10, and then 2 goes into 50, 25 times, right? Half of 50 is 25, so. We're just trying to find 2. Very good. And that will give us okay, this is where I would definitely go back to my original problem, wherever that is. Yeah, at the very top, and check my answer. So technically we only came up with one answer, right? We don't have 2 answers here. So the idea is this should be our correct answer, but since we know we can get extraneous roots, you do want to check your answer just to be 100% sure that, hey, this is the answer I'm supposed to get. So let's do a little check here. It's D equals square root of P minus square root of P minus 400. They're telling us if you have 10 suits, our price is coming out to be $625. So that's P as 625. Square root of 625. Yeah, because we did 25 squared to get that. So this will be 25. And $15, very nice. And what's 25 minus 15? Alrighty, so that's what we are hoping, that we should get a true statement when we check our answer. So then we know that for 10 suits, or basically if the demand is 10 suits, then your price will be $625. And that number works because we checked it. Yes. Tuesdays from 1 to 2:15, though tomorrow college is closed. So tutoring will be then Wednesday, 3 to 4. Wednesday. Well, obviously we're not doing the test because we still have 1.7 to finish. No. No, I'll change the due date. How far? All right, questions on this guy?
I have a question. So what if you change the demand of the suits to something else?
Then the price will change. Because remember, the idea is the more suits you have, technically the cheaper, the price should go down, right? Because you are more efficient basically in the production.
Right. But if you set D equals, say, like 25, so
you would be going through the same math
in that,
and figuring out
and that equation would still balance.
Hopefully. Because if the price would be equivalent to that demand, then because it looks like in this example, we're not getting an extraneous answer, right? There's no extra answer.
Right.
So technically, if you do a demand of 25 suits, then you should get the equivalent dollar price. What else?
Do you do research on the quizzes or on the exam?
On the exam, no. Do you mean like fixing?
Yeah, like let's say you got like a 60%, you think you can do a better job.
Okay, no, sorry. All right, guys, let's go ahead and see how much of 1.7 we can do. If we can do it today, that would be awesome. So this one is actually getting into absolute value inequalities and linear
inequalities.
You know what, let me start this over.